Welcome to the new section of this course, Flux and Mono in Spring. Now let's move on to the video, Benefits of Reactive Programming. Reactive Program is all about non-blocking applications that are synchronous and event-driven, and it doesn't require a lot of threads to scale vertically rather than horizontally. Reactive types are not intended to process requests faster. However, they focus more on request concurrency, especially requesting data from a remote server efficiently. With reactive type support, you will get higher quality service. While comparing traditional processing, which blocks the current thread while waiting for a result, a reactive API requests only the amount of data that can be consumed. APIs deal with streams of data, not only with individual elements one by one. Now let's see Reactive Core and Streams. Java 8 introduced Reactive Core, which implements the reactive programming model and is built on top of the Reactive Streams specification, a standard for building reactive applications. As the Lambda syntax gives more flexibility to go for the event-driven approach, Java 8 provides the best way to support reactive. Also, Java's Lambda syntax gives us the ability to create and spawn up small and independent asynchronous tasks. One of the main goals of reactive streams is to address the problem of backpressure. The main difference between Java 8 streams and reactive streams is that reactive is a push model, whereas Java 8 streams focuses on pulling. In reactive streams, based on consumer needs and numbers, all events will be pushed to consumers. Reactive programming model support is Spring 5's best feature since the last release. Also, with the support of the Akka and Play framework, Java 8 provides a better platform for reactive applications. Reactor is built on top of the reactive streams specification. Reactive Streams is a bundle of 4 Java interfaces: Publisher, Subscriber, Subscription, and Processor. Publisher will publish a stream of data items to the subscribers that registered with the publisher. Using an executor, the publisher publishes the items to the subscriber. Also, Publisher makes sure that the subscriber method invocations for each subscription are strictly ordered. Subscriber consumes items only when requested. You can cancel the receiving process anytime by using Subscription. Subscription behaves as a message mediator between the publisher and the subscriber. Processor represents a processing stage which can include both subscriber and a publisher. Processor can initiate backpressure and cancel the subscription as well. Reactive Streams is a specification for asynchronous stream processing, which means all events can be produced and consumed asynchronously. After that, let's see backpressures and reactive streams. Backpressure is a mechanism that authorizes the receiver to define how much data it wants from the emitter, data provider. The main objective of reactive streams is all about handling backpressure. It allows the control to go to the receiver to get data after it is ready to be processed, defining and controlling the amount of data to be received. Efficient handling of the slow emitter, fast receiver, or fast emitter, slow receiver scenarios. Next, we will understand Web Flux. Spring 5 introduced a reactive web framework called Spring Web Flux. It is a non-blocking web framework that uses Reactor to support the Reactive Streams API. This concept will be mainly used in mobile applications and microservices. Also, this Web Flux will be the best fix for scenarios with many clients and uneven workloads. Now we will see some basic REST API. To understand the practical part of reactive components such as Flux and Mono, we will have to create our own REST API and start implementing Flux and Mono classes in our API. So let's start with Flux. Flux is one of the main types in Reactor. A Flux is the equivalent of an RxJava observable capable of emitting 0 or more items and then optionally either completing or failing. Flux is one of the reactive types that implement the publisher interface from the Reactive Streams manifesto. Flux's main role is to deal with the streams of data. Flux mainly represents a stream of n elements. Flux is a publisher, a sequence of events of a specific plain old Java object, POJO type. Next is the Mono. Mono is another type of reactor that can emit only one item at the most. An asynchronous task that just wants to signal completion can use a Mono. Mono mainly deals with a stream of one element as opposed to Flux's n elements. Mono is used in specific scenarios like an HTTP request that produces only one response. In such cases, using Mono would be the right choice. Mono can be used to represent no-value asynchronous processes that only have the concept of completion. Both Flux and Mono make use of this semantic by coercing to the relevant type when using some operations. Both are reactive streams, RS, publisher implementations, and conform to reactive pullback pressure. This is it for the video.